Okay. Hi. Happy Wednesday, everyone. It is Wednesday, my dudes. Um, it is Wednesday. I'm sorry I'm running a little bit late. Very busy, preoccupied day right now. So this is going to have to be a quick stream, but I wanted to make sure I got a stream in today. I wanted to make sure I didn't fall off the wagon or anything like that. So yesterday, let's just do a quick recap of the big thing that we started yesterday was enemies. We started adding like a guy that your ball can collide with, and I mean, yeah, you can collide with. Yeah, there we go. I was like, I wanted to show the collision, but I had to get the ball to actually collide with that. So we started adding that. So right now we just have one enemy that is there and that just does the one thing, which is move across the screen from left to right. Nothing fancy. So what I want to do is I want to start adding support for multiple enemies. Something which would be extremely straightforward if I had a real programming language. Things like on a real CPU with structures and arrays and stuff. But we don't, so there's going to be a few interesting things to note. Like, if I were writing in C or something, I'd be like struct enemy. I guess I need to do like a type def or whatever, but you know what I mean. Struct enemy, I'd be like int x, int y, int x velocity, int y velocity, and I'd have like enemies, and I'd say, oh, we can have 16 enemies or something like that. And I just build an array, and it would be extremely straightforward to take the code that I wrote and just use it for a list, iterate over that list of enemies and do the updates. Unfortunately, the Game Boy assembly language is not a real programming language. The Game Boy CPU is not a real CPU. Trying to do something like this would actually be really, really slow and unpleasant. So the big thing that we're going to do, that I'm going to introduce, is this idea of instead of using a struct and an array of structs, we're instead going to have, well, you could say like a struct of arrays. There won't actually be a struct. We're just going to have a bunch of arrays for each of these things. We have like int enemy x's. Like this is roughly the equivalent. And this actually makes things much, much easier and more efficient on the Game Boy in a manner in which I will show you as we go along. I probably won't add support for up to 16 enemies. That's a lot of enemies. I mean, I don't know. It doesn't really matter. 8 maybe, 16, who cares? Not the point. So yeah, I'm just going to try to get that knocked out real quick. So, where do we begin? I'd say let's go over to game, which is where I've got this enemy code. Say 8 for now. So I'm just going to do that, all of these things. Create these arrays. And what I decided to do yesterday is, instead of like adding the ability to destroy an enemy or something like that, I'm just going to put the enemy off screen and set its movement to 0. So that way it's just off screen. Rather than have to worry about like, oh, how big is the array, or dynamically moving things around in the array, or anything like that. We're just going to act as though we've got 8 enemies all the time. Which is actually a reason why to limit this, because I built that on purpose so I could get a list of places where we have errors. Hi, Nellie. Hey, are you a cat? Oh, sorry. I probably could have lifted you a little more gently. This is my cat. Millie, say hi to the internet. You are a cat. Yeah, a reason to keep the number of enemies down in particular is that if we are iterating over every possible enemy every frame and doing collision detection against every possible enemy every frame, it's going to start eating into our CPU usage. And we can like look like, what is our CPU usage like? Oh, whoa, no, don't want to do that. Like right now we're totally fine. We're like beyond that. Like that's what, maybe 10%. But it can go up very, very quickly because the Game Boy is very slow and collision detection on the Game Boy tends to be very slow. So, God, what a good cat. Love you, Nelly. Thank you for being my cat. You're so good at catting. I feel like I might be weirdly overly affectionate with my cat. I'm gonna blame the pandemic on that, like just being. She's my #1 source of like other living interaction. So I'm at home all the time. So let's go down to game. Where is it? 41. Yeah. I'm just gonna do enemies. Perfect. Okay. Okay, there we go. Make sure you can. For the internet. For the internet. So yeah, instead of having init enemy whatever, we're gonna have call init enemy x's, call init enemy y's, call maybe this is excessive, but or I could like count on the fact that they're all right next to each other and just do sort of like a zero out thing, but no matter. And then the x's. Just really bog standard loops here. You might be wondering, Adam, why don't you just write one procedure that you can use to fill memory or something like that? And well, the answer is that doing that would save virtually no space. This opcode is 1 byte, that opcode is 1 byte, that opcode is 2 bytes. So this sum total, 4 bytes. The call instruction is 3 bytes. It would save 1 byte of memory. So I just generally don't like to bother doing it. Or 1 byte of ROM, I should say, not 1 byte of memory. Like, yeah, that adds up after a little while, I guess. But I sort of don't like to have. It's weird. When I program in a high-level programming language, I'm all about factoring everything into super, super tiny functions as much as possible. In assembly language, where there's like no good way to enforce things like functions, like calling conventions, types, and register what registers get destroyed or whatever, which registers get preserved. There's no way to preserve any of that. Every procedure call has like kind of some overhead, um, and especially a reusable procedure. Like if you try to do it as a function, you start to get to like really weird, exhausting states where it's like, oh, I wrote this function so that it trashes this particular register, but I need to preserve this register. Now I need to remember to push to the stack and pop from the stack, and oh, whoops, I forgot the calling convention, or I accidentally screwed up the calling convention. Now things are behaving erratically, and I have no idea what the hell's going on. It's just like cognitive overhead. So I just prefer to write out these loops, even if they are very repetitive and there's lots of code duplication. Maybe there's a case that even if I'm not going to use a procedure, I should use a macro or something like that. But eh. I mean, another thing is right now I'm just putting all of the enemies in the exact same spot and having them all go. I don't know, like I want to have different velocities for them, I guess. So instead of giving them a fixed velocity like I'm doing now, I'm going to just go to HL, enemy velocity, x's, loop. I'll just do something to spice it up a little bit. I'm just going to end it with those two, just to get like some kind of variation. I'll do the. I guess I'll do the same with the y. So now they'll be moving diagonally instead of. So that'll init all of those. So we just have these 4 routines. We're going to call all of those. I guess that's called by the collider routine. So what I'm going to do is I'm going to have a variable. So this is going to be called like current enemy. We're just going to use this to keep track of whichever enemy we're in the middle of updating. That's going to what we're going to need. So I might just call this destroy current enemy. Column is that? Column 25. So I guess here is where things start to get a little bit interesting. We don't just have an enemy x variable that we can write into, or an enemy y variable that we can write into. Finally. Like what we want to do in programming, like in in C terms or whatever, would be something like this, but we can't do that. That is not a thing that you can do on the Game Boy directly. So this is why sort of why I needed to use this like separate arrays rather than a struct. It's because we have to do something like this, but we can't do it automatically. But it's not too hard to do it. What's even worse is trying to do something like that. That takes all of the complexity involved in this, and then adds all the additional complexity of doing that. So I'm actually gonna off screen. Gonna have a separate routine for this because it's gonna be unpleasant. So you can see what we did here is we have to do this sort of indexing operation manually. We first initialize, and this is actually a simplified form which assumes, hopefully correctly, that enemy X is across the whole array, the upper byte of the address of it is fixed. If I were more diligent, I would add some kind of assertion to make sure that that was the case, but I'm just not going to do it, and hopefully if it introduces a bug, it'll break violently instead of subtly. So we then get the current enemy, and this is why the struct thing is so important, I guess. We get the current enemy. To index into the array, all we need to do is just add from the base the current enemy. If every entry in the array was bigger than 1 byte, we need to multiply to figure out how far into the array to update the address. So that's why doing it with a struct is very difficult. Like best case scenario, your structs are powers of 2 aligned, and then the multiplication is only, some rotate instructions or shift instructions or an add instruction away to double or quadruple or whatever. But like a worst case scenario is that it's not a power of 2, and then you have to do some kind of slow software multiplication. Like it's a disaster. So this is why using an array, using separate arrays for each field is going to be faster than using an array of structs. It's that you can skip this multiplication while indexing. So given that, we've now built the address that we are looking for. We're just going to load A with 200s, write it. Actually, we don't even need to load A. What am I doing? Just write it. I just always forget that particular instruction exists. Usually you can't just write into memory like that. It's kind of a special case. And then we're going to do the exact same thing for the, sorry. Oh my. I had the word combination in my brain when I was thinking about like the combination of these two things. I just said it or wrote it. Okay, so call it stop. That's the other thing we're going to do. And stop current enemy is going to look very, very similar because it's just doing kind of the same thing, except it's doing with the velocities, and it's writing 0 in. sure I got that right. Enemy velocity. Hi, Nelly. So that looks good to me. Let's build, see what errors there are. First notable errors on line 41. Oh, Nelly. Oh. No, why would that be a... Did it fail to assemble? Yeah, okay. It failed to assemble. Line 49. Knit enemy. Oh, I just had it in there twice for some reason. Okay. Now it looks like it actually assembled. So now let's go down to... No, still didn't. Nelly, why are you so squawky all the time? Baby. Baby. Position. Oh. Stop for enemy. Whoops. There we go. So what's the next error? The next error is on line 139. Right, we've got this update enemy routine. I'm going to rename this update current enemy. And we're going to have an update enemies routine. It's going to be the basis of what we're going to do here. And all this is going to do is it's going to be a loop. So we're going to start by clearing out A. Now normally, you prefer to count down in loops. That way you can use the decrement operation from 1 to 0 will raise the 0 flag. And then you can use that to terminate your loop. But here we want the actual... Well, I guess I can just... Actually, I take it back. We can just update the enemies backwards. I'm just thinking about the best way to do this, sorry. Like what we're ultimately going to want to do is call update current enemy, and then we're going to want to load HL with current enemy decrement HL. So actually what I might want to do is just write away from this. -1. So this is going to iterate through that array backwards. It's going to update the current enemy, and then it's going to, and I need to actually do the loop condition. It's just going to move backwards through the array, updating each enemy. And whichever enemy it's updating is going to be in this current enemy variable. This is probably the best way to write it. So then I'm going to go up here to update current enemy. We don't need to. And this is going to be similar but different. Right, it's going to be very, very similar to what we did up above. We're going to start with just that we got to compute everything, which is sort of exhausting. Right, so we're going to go gradient the high enemy x's. We're going to get the current enemy we're going to add low enemy X's. And then because to get the velocity, we're going to need HL as well because we're getting a new address. I'm going to put it into B instead of just doing the direct add. Sorry. Load B with HL. And we do the same thing again to get the enemy velocity X. Now I'm going to get it back from B, add HL, and then load. I'm going to do this actually the other way around, and you'll see why in a second. Well, you might see why in a second. It depends on how well I explain it, probably. So we get the velocity, put it into L, put it into B, sorry. Then we're going to get the enemy X position. Baby. What a cute baby. Oh. You're so good. You're so good, Nelly. So then we get the velocity back. The velocity was in B. We put it into B up here. And then we're going to add it and write it back into the enemy X array. And then we just do the same thing for the Y. Oop, that is not what I wanted. Why is it doing? Oh, because I'm using this awesome column selection mode that I love, but I always forget that I'm using. And then I just got to update all these to use the Y's. Now they get on camera. Earn your keep. So, cool, done that. That is done. That updates the current enemy. That goes to the list. Let's build and see where we have errors. Line 133. This should be update enemies. 178. Set up enemy OAM. And this is going to be kind of, this is going to be more of the same. I suppose the annoying thing is that, I hate using DE for things beside. This is completely psychological. So the register pair DE, I like to use it for destinations because that's DE kind of reminds me of. Like HL will be the source, DE will be the destination for like a standard copy. But here I'm actually going to do it the other way around because it's going to be faster this way. Here the source is going to be coming from DE and the destination is going to go into HL. So just all the same stuff that I was showing you before about how to deal with these arrays. And again, I want to make clear that I'm being doing it this way is prone to bugs or prone to issues if the high the high byte of the address of something later in the array is different because it like crosses if it spans a page, if it goes from like hypothetically 00FF to like 100 or sorry 1000, no 100, sorry 100, like that means that like the low earlier in the array the high byte is 0, and then later in the array the high byte is 1, and we're not accounting for that possibility here. And my general attitude towards this is that this is unlikely to happen. Hopefully, if it does happen, things will break quickly and violently. The ways to avoid this from breaking things is to use asserts to tell the assembler to like scream if that ever happens, and then you can like rejigger things around to make sure that it doesn't happen. Or you can allocate a byte at the end of every page. I call it a page. Like so at 00FF, 01FF, 02FF, you can allocate a byte, and that way the assembler will never be allowed to stretch memory across an array across that byte. That's probably the best way to do it, but it's a pain in the butt. So I don't. It's not even that much of a pain in the butt. It does get annoying because then if you start having like really big arrays, like an array of 256 bytes is a really common tactic for things. And then if you've got that array, you're going to start running out of pages that it can go in if you've got these barriers everywhere. So then you need to like manually start deleting your barriers to accommodate things, and it's so annoying. I don't believe I'm muted. Am I muted? I mean, I'm not muted. Oh, you are muted. It's like a Zoom call. It happens all the time. When I was working, I quit my job at the end of December to take some time off for a whole bunch of reasons. And but before that, there was a good solid like 8 months of work from home during the pandemic. And I don't think I ever had a single Zoom call where at least one person, usually myself, didn't start talking and then like realize, oh no, I'm muted. It happened constantly. So we're gonna yeah. Okay. Hi, Nelly. Set that to enemies. Set up enemy OEM. So this is like going to be a weird change. I'm going to take the setup enemy OEM. I'm going to actually put it as part of this loop. And of course, rename it. And I say it's a weird change because right now I've got the setup ball OEM separate from update ball and setup paddle OEM separate from paddle. So there's like an inconsistency there, which is not great. And I might at some point move this into update ball and this into setup or update paddle, but not today. It's not a thing that I'm doing today. And I'm actually going to do something very similar with the collision. Right now I've got a totally separate thing, which I guess I call from ball, where I check enemy collide X and check enemy collide Y. And I'm actually going to do this as part of the enemy code. instead of part of the ball code. So that way I can just have this one big loop that goes through all the enemies and updates all the enemies and does all the handling related to the enemies in one go. And that's also weird because the ball, right now, as written, the ball is responsible for checking all of its collision with everything. So hopefully that doesn't introduce any kinds of problems. So let's see, what I'm going to do though. I'm going to go into collide. What do I have? I've got these two routines here, which are check enemy collide X and check enemy collide Y. I'm going to rename these. And these are kind of going to hinge on that current enemy variable that I'm using for the main game loop. Column selection mode. There's a key binding to switch into that. Oh, I'm sure I could set one up. But we're going to check current enemy collide. And I'm just doing these naming changes to make sure everything is like really, really clear. Like, which enemy am I colliding with? Well, it's the current enemy. Is this going to work? I mean, this is going to work, but I might have to do this as part of the ball movement. I might have to do this as part of the ball movement anyways, because the idea is that we want to detect, like, as part of the move to the X, that move across the X-axis, that's what triggered the collision. So I'm going to just have to have the ball do a totally separate loop, which is fine. It's not the end of the world. But it's one of those things where I don't like it because I already have a whole bunch of stuff doing stuff with this current enemy variable, and it's going to be weird, but it's fine. It's fine. Oh, I need to actually forgot to invoke enemy here. Actually, I'll probably put that into destroy current enemy, but whatever. I'm gonna leave that comment for myself there. What next? Right, I guess I need to fix this to do what I need it to do. So this stays the same. This all stays the same, but this has to change because there's no more enemy X. There's an array of enemy X's. Yeah, I'll have to iterate in ball. There's an array of enemy X's. So that's where, I don't use HL anymore here, so this shouldn't be too bad. So just load H, hi, enemy X's, load A, current enemy, load, add low, and X's, do this sort of standard pattern for array iterating. It's fine, yeah, right? Famous last words, all the time, forever. It's always fine until it's not. But that's okay. That all stays the same. And X, just add that here. Check. Just adding some extra comments now because the code is getting kind of thorny. Y, super similar. So enemy Y's, enemy Y's. Check. I think that does it for this. I think that'll get that working. And then the last thing, let me build it, make sure that builds. Now, the last thing I need to do is go over to ball. And I need to do, I'm going to actually call check collide. Check enemies collide X. Naming is starting to get really weird here. But this is going to be very much the same as what I do is in like the main game loop for updating all of the enemies. We're just going to get the number of enemies -1. Load that into current enemy to kick the loop off. And then we're going to do this loop. Okay. Call, check to see if we've got a collision. And repeat. And then I'm going to want to have very much something very similar again for Y's. Yeah? She's just like walked past the door, screamed, and kept going. Oh, and these are now check current enemy collide. We're going to have, yeah, I got to do an update ball Y, the same thing. Check enemies collide Y. Yeah? Nelly? Oh. Nelly, no, stop eating my, no. Nelly, that's not food. That's furniture. Oh. There we go. And we got the cat. Cat in action. And I'm going to create a new file here, anticipating when I do my refactor. This is going to be enemies.inc. We're going to include enemies.inc. Include enemies.inc. And we're going to have to do that in ball.asm as well. Okay. Now it compiled. Let's see if it works. Sure doesn't. What is this? This is loading the current enemy. This is an update current enemy. And what is the thing here we are reading? Now, here is where I check something. No, these all stayed within the same page. Good. So that is not the issue. Yeah, where's my debugger? Show me my debugger. Here's my debugger. Current enemy is 7. I have a typo somewhere. What is the specific? The fact that these are both C0 isn't crazy, but makes me a little suspicious. But okay. Is this enemy velocity wise? I think this is enemy velocity wise. I probably am not emitting my enemy velocity wise correctly. So let me double check this. Yeah, that is the problem. Build. reload, run. God, what did I do? That doesn't look right. Window size. That looks quite wrong. Why is that happening? Doesn't surprise me that it looks wrong, but it looks wrong nevertheless. So B contains the velocity. Then we get the x. That's what's wrong. And probably the same thing over here. I think that's right. It just looks weird because all of them are moving at the same, roughly the same kind of pace. But I think that's right. I think that's what I was looking for. On the other hand, oh, that's what's wrong. We're not setting up the OAM for everything correctly. Right. Got it. We're always overwriting the same OAM slot. So what might make sense to do is it might actually make sense to do this in a separate, completely separate loop. Yeah, that's what makes sense. I'm gonna call this setup enemy OAMs. Didn't totally think this through. Not totally unexpected. I'm gonna get rid of that there. I'm gonna go to here. This is nice. This restores that symmetry that I was complaining about earlier. We're gonna set up enemy OEMs. So I'm actually gonna do this in 3 separate procedures. It's a little slow, but it's simpler. Like, rather than trying to maintain a pointer to the x's and a pointer to the y's, and the pointer into the OAM that we're writing into, I'm just going to do 3 separate loops. This isn't, it doesn't have to be particularly performance sensitive. Oh, and actually, because now I get to do I was complaining earlier that I prefer it when DE is my destination, and I get to do that now. All I do is I pull the enemy Y from there. I write it into DE, and then I need to add 4 to DE to get to the next, sorry. I need to add 4 to it to get to the next slot, and then I do my, so that is the Y's. I'm just going to copy and paste because it's going to be really, really similar. What are the differences? We're going to start from the X's. We're going to start with an offset of 1 to be pointing to the X's consistently, and that's actually it. And then the tiles, even simpler. Here, we're going to just use HL plus 3 to get to the tile number. Enemy tile. Even simpler. Oh, and this is not X's, this is tile. I think that's everything. Wow. So, not totally correct because we're writing the wrong tiles in, but aside from that, it's working. Why is that on? It is +2, not +3. So, very weird, but it's doing its thing. Although that's a little weird. We're not bouncing properly off of them anymore. That's kind of a concern. I don't know what's happening there. Actually, I've got a good guess as to what's happening there. I think what's happening is that there's multiple. No, something weird's going on. It's not quite working the way I want it to, as you can see. But do I clear OAM on each loop? That might be the failure that's going on here. No, but that shouldn't actually matter, because, yeah, no, that's not it. What could be wrong here? What could be going wrong? Like my initial impulse. I might be failing to destroy them properly. Add L, load L. Write that in. I am. That might fix it. What just happened there wasn't unexpected because there's multiple enemies in that location. That was a little unexpected. Just cut right through. I'm so Should I save and rebuild? I really thought that that was it. Add high enemy loadout. So we just draw it off screen. That feels like it should work. I did rebuild there. I did save, rebuild. It's like kind of working. It's just not working totally. Let me go back over into Collide. The current enemy should be correct here because I'm invoking this. Let me go check out my loop. Check enemies collide X, check enemies collide Y. That all seems really good to me. So what I'm going to do is I'm going to just cut down the number of enemies to just one, which will hopefully not break everything. No, it won't break everything. I'm going to cut down the number of enemies to one. I'm going to hit reload. I'm going to hit run. Totally broke everything. What is going on here? Update current enemy. I'm going to set the number of enemies to 2. I'm a little surprised that broke everything, but okay. So now we just have 2 enemies going back and forth. And we just sliced right through that guy. Why did that happen? That's what we're going to figure out. Check enemy. What is it? It's too many dang check enemies collide. X and check enemies collide Y. I'm just going to hit reset and I'm going to hit run and we're just going to see if we can figure it out from here. So that's going to get called. So we're going to say load A current enemy. Oh, it's because we're not checking. It's because I'm screwing this up terribly. We're not checking collision on the 0th guy. We check collision on the first guy, and then we decrement, and we hit 0, and of course it doesn't work. So then the question is, how do I want to do this? Do I want to change my loop conditions, or do I want to... Do I want to change my loop conditions, or do I want to subtract 1 every time I access memory? It seems obvious. Like, let's change our loop conditions. Right, this doesn't work. I wanted it to work. It doesn't work. I wanted to do the backwards counting loop, but it just doesn't work, so we won't. We count forwards. I have to do that. It's a fact of life. Because the problem was it would go down to 0 to do the 0th element, but that would be what triggered the return flag. So I could either do what I'm doing, which is now I'm going to count forwards and just manually compare at the end of the loop to see if it's 8 or not, or the number of enemies or not, the index is the number of enemies or not. Or I could keep doing what I was doing, but just add 1 to the number of loops that I do, so that I do the right number of loops. But then in order to actually get the current enemy, I need to manually adjust it. I need to manually subtract 1 from it every time, and I don't want to do that. So I'm gonna do this instead. And I need to do that for the update routine as well, over in game.asm. Tried to be clever and I got burnt. As per usual. Now I'm confident that that's correct. I'm going to hit reload. I'm going to hit run. And we're going to see. Yeah, now we're talking. Oh God. Yeah, there we go. And that looked. Yeah, that looked like it worked. So now I'm going to jack up the number of enemies back up to 8 for more fun. I don't know if I think they were built there. Reload ROM, run. Now we've got 8 enemies. I don't like how that just cut through that one. That didn't look right to me. I think I know maybe why that happened. I think it's because the ball was colliding with both enemies at the same time. So it bounced once, or it hit one enemy, it bounced and destroyed that enemy, but then it hit the other enemy and bounced and destroyed it. So I think that's what's happening there. And the way I could work around that, and I guess it's just a matter of, do I think I should probably work around that, huh? So all I have to do there is, instead of reflect ball Y, I need to call bounce Y. Instead of reflect ball X, I need to call bounce X. And all this does is when it hits the enemy, it's going to change direction and apply the reversed velocity again before doing the next collision check. So that way it'll only destroy one of the enemies if they're on top of each other. That's probably not something that's like an actual real concern in actual gameplay and not in just test gameplay, but yeah, so you can see there that did basically what I want. It still looked a little weird, but I think that's what I want to do. Cool. That is going to have to be it for today. I have to do kind of a short stream because I've got a bunch of stuff going on and I'm busy. So shortish stream, but I wanted to make sure I got one in today. Add support for multiple, maybe even, well, I'm going to leave that to do in there for now because there's enemies, but I wouldn't say that it's done quite yet. I guess the next thing I need to do is I need to have some way to indicate as part of the level data what enemies are there, how many enemies there are, where the enemies are, like that sort of thing. So that's probably what I'll do tomorrow. But I wanted to get that in for today. So cool, that is it. Even though I kind of had to rush through it, that was, I think, actually a really sort of important lesson like learning how to use this whole pattern that I did with the to do the arrays, and like use multiple arrays instead of a array of structs. That's like a really crucial pattern when you're doing this kind of thing. This kind of thing being Game Boy game programming. So it's really key. Everything else in the game so far pretty much has been kind of like there's one paddle, one ball, so I haven't had to like deal with this kind of thing. But now I have, and that'll be useful when we start doing other things. If we start doing things like adding animations, we might want to have multiple animations going on the screen at the time. I want to add multiple balls, power-ups. All those things are going to require arrays. So it's good to like get this logic in now. Anyways, cool. Thank you for watching. I gotta run. It has been a blast. Take it easy. Happy Wednesday. I will be back tomorrow with more stuff. Cool. See you around.